Anders were there earlier.
His third cup of coffee, but here we
But it was pot of coffee. So
This is from coffee. Says
that's it. Been in some military things. And he drinks coffee.
fair enough.
All right, as for today, all right, we are continuing in chapter 2. Now we're going to get into some of the good stuff, all right, that is the word problems, all right, and then some formulaic type solving. So the biggest thing with word problems in general that I need to mention is don't panic. Everyone sees the words immediately and they're like, oh my God, I don't know what I'm doing. I just throw up my hands and I'm done. But that's how most problems are. And again, I teach statistics, so this is definitely where I put the emphasis because that's what a real world problem is. Okay, now these are simplified versions, all right, because in the real world, someone comes up and explains to you for half an hour. This takes all of 1 minute to read, right? But people still panic over this. Okay, so take a breath. All right, we're going to read through it and do one piece at a time. All right, so there has been a long debate about the use of between Celsius and Fahrenheit. Celsius uses the boiling point of water, 100 degrees, while the boiling point of water in Fahrenheit is 212 degrees. FY, Celsius was based on water. Okay, freezing is 0 Celsius, boiling is 100 degrees Celsius. Does anyone know what Fahrenheit was based on?
No.
Guy,
I'll help. What?
someone's name?
Oh, yes, it is, but so is Celsius. It was based on a liquid. What liquid is it based on?
Mercury?
Nope. That is what's in temperature gauges, right? Fahrenheit. That name is German. What liquid do Germans love? Beer. It's based on alcohol. All right. All right. The boiling point. All right. They identified Fahrenheit to be based on alcohol with an estimate of approximate human body temperatures. So just as a fun fact. Someone says 31 degrees Celsius today. What is the temperature in Fahrenheit? The conversion formula is given as follows. So, all right, basic algebra. When we plug this in, Celsius is 31 degrees, and we have our equation 5/9. Fahrenheit minus 32. When we go to solve this, all right, we should be familiar with our approach now. Rainbow, right? We love the rainbow. Right, I'm just gonna put this in decimal for the moment. And mostly because we're gonna get a decimal value out of here. Now, be aware, this is something else in your calculator that I absolutely love. When you put, right, a value into your calculator, it can spit out a decimal or it spits out a fraction depending upon your initial settings, all right? But you can always hit the math frac button, all right? That says turn that number into the fraction. If you use that, that number there would be 1/69. So I'm a big believer in like using the technology wherever we can. All right. And again, once you get to statistics, all we do is use technology and interpret. Okay. So the idea is that we want to cut down whatever difficulty we have. And since everyone hates dealing with fractions, we want to be able to kind of fluidly go back and forth here. All right. Once I have this, then this should be a piece of cake. What do?
Whatever you do on one side, you do the other to solve.
Yes. So specifically,
Add.
add 17 and some change or 1/69. I'm out of room already. And then lastly, what do we need to do?
It would be divide by 5/9, wouldn't it?
Divide by 5/9, or just to refresh, all right, since I'm doing this one in the calculator, because the fraction is not the point here. When you have a fraction, instead of dividing by 5/9, what else can we do?
Do the math frac to figure out the decimal for that?
I mean, yes, absolutely, I could. But you, instead of dividing by 5/9, you can multiply by 9/5, right? Just as an FYI. Cancel, cancel, F equals. So the Fahrenheit temperature, 87.81 degrees, which is why this number makes a lot more sense as a decimal because, or at best, a mixed number, all right? Because with this, all right, we have Fahrenheit as a value that everyone should be at least relatively familiar with, and decimal makes a lot more sense. All right, the point is nothing there was overly complicated. That's all stuff that we're pretty familiar with. All right, don't panic when you get to words. The angle measure S of a sector of a circle is given by the following formula. All right, where R is the radius, A is the area of the sector, and S is the degrees. Solve for R. This is the style of problem that people hate the most, because this is an equation, right, where I have S and then I have several inputs. And all this is saying for is rework this to be R equals. So you're not actually getting a number out of it like we did in the last problem. I'm simply reworking this to solve for this R. And you really have to understand your rules of algebra to be able to do this, because you do the same things, just one piece at a time. And no, we're not going to be able to simplify any numbers here. So with this, I'm trying to isolate R. What should be my first step?
The exponent.
Go ahead.
The exponent.
The X, that's actually going to be the last step.
Is it the last one?
But yes, that is something I need to focus on, but that's the last step.
Move it to the numerator.
The numerator, and essentially numerate the fraction part, right? We hate fractions, so we want to eliminate them. We actually minorly discussed this last time. This is S over 1, right? If I have a fraction equals a fraction, what's that technique called? Where I can crisscross them, cross multiply. This is actually one of the biggest cases where you can use cross multiplication. Or the same concept is multiply both sides by pi r squared. That would be the same thing algebraically. The fast way is to do cross multiplication here. But if I multiply both sides by pi over r squared, and let's just put it over 1, equals 360a pi over r squared times pi r squared over 1. Right? What happens on the right side?
It just cancels out.
They just cancel. And so then I have S pi r squared equals 360a. Now this is just a slower version of what cross multiplication is. But most people, is cross multiplication, most people that's the one thing they love and remember. No, are we kind of rusty there? The algebra is the same concept, just slightly slower. Okay, so now we have pi r squared S equals 360a. Now remember, we're solving for R. Okay, so pi is being multiplied by R, S is being multiplied by R. What's the opposite of multiplying? Divide. So let's divide by pi S. What's left on the left side?
R squared.
R squared, right? Cancel, 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 cancel. And we're left with R squared, all right? And as you mentioned now, all right? Our last step, again, we're trying to get R equals. So what's the opposite of squaring?
Dividing.
Square root.
Ooh, square rooting. All right, now we're in exponents. Remember, we do PEMDAS in reverse. Okay, and the last thing, that E, all right, exponents, square root, cube root, 12th and 12th root. So square root both sides. Those cancel out. R equals the square root of 360 A pi S. And a lot of people really dislike this because all we did is just adjust. There is no X equals 5, R equals 7 here, okay? This is really understanding the rules of algebra because I'm just rewriting the equation. All right, this is what people struggle with the most. All right, so definitely focus on this. This is on the activity. All right. But if you're struggling here, you will not be alone because you have to understand the fundamental parts of algebra here. Along those lines, A equals P plus PRT. This is the simple interest formula for a future value given principal, interest rate, and time t in years. All right. The most basic form of finance math, which everyone, in whatever next class you have, you will definitely go through. All right. Because, are we doing okay?
Yeah.
Okay. So in this case, once again, all right, this is currently solved for A. I want to solve this one for P. This one starts out with kind of a fundamental concept. I have P plus other things with P. So I have P in both of these. I need to pull a P out. Does anyone remember what that's called? When you remove a P from, and it might be easier to see if we have 7x plus 49. When I pull a 7 out of there, right? Factoring, right? I pull 7 out of there and I'm left with x plus 7. All right. So same thing here. If I pull a P out of this, what's left in the first term?
P.
A one.
A 1. Right? 1 times P makes P. Separated by an addition, what's left in the second term?
RT.
RT. Factoring is, right, factoring is kind of in between division and multiplication, all right? When I rainbow this back in, I end up right back here, all right? Factoring is really reverse distributing, okay? So it's not quite dividing yet, but that's the big part there, all right? I factor that out, and then, once again, we're solving for P. So P is being multiplied by 1 plus RT. What's the opposite of multiplying?
Dividing.
Divide. So divide both sides by 1 plus RT. And we're all done. Again, notice again, I have the same exact equation solved for a different variable. So there is no A equals or P equals 7. All right, we are using the fundamental principles of algebra in order to break these down. You guys all with me? And again, this is the part that everyone struggles with the most. So we're gonna pay attention to these as we go. Something that we use all the time, and definitely this is one of the big concepts in stats. So I want to make sure everyone gets this. Percentage use, and we talked about this even on day 1 as well. When dealing mathematically with percentages, we convert them to decimals, okay? All of these are equivalent, 20%, 20 out of 100, 20 times 1 out of 100, 20 times 0.01, all right? All resulting in 0.2. Okay? We should seamlessly be able to transition between those. Probabilities, all right, are what we deal with the most. But people don't like saying, oh, what's the chance it's going to rain? 0.5. They don't like that, right? So we say, what's the chance it's going to rain? 50%. But mathematically, we have to use the decimals to deal with them. Percentages were only created because people like values between 0 and 100, okay? But the actual chance it's going to rain is 0.5. That's why we always have to make sure you say 50%. What chance it's going to rain? 50. No. Okay, so make sure, all right, that unit is important. What percent of 150 is 39? In order to solve these, we basically pulling out the mathematical language directly. Of means what mathematically?
Multiplying.
Multiplying. Okay, so what percent? Let's call that X. Of means multiply. 150 is means what mathematically? Equals 39. So these translate directly. All right. English language to mathematical language, exact translation, as long as you understand what the words mean. Of multiply is equals. And then, all right, then I have myself an equation. 150x equals 39. In order to solve it, divide by 150. Now, be aware, I am absolutely fine. It says what percent? The answer is 0.26. I'm fine with you guys leaving it that way because that is the probability and that's perfectly fine. Pearson is going to be a little bit particular. So if it says percent, make sure you actually convert to the 26%. But if I give that on a test or whatever, or at your activities, 0.26 and 26%, they're the same to me. 54 is 24% of what number? Same thing. 54 is equals 24%. 0.24. Make sure we write that correctly for our calculation of what number? X. And once again, once you translate these, I mean, the math is very simple, right? The translation, which is again, as soon as people see words, they just panic and fall apart. Don't fall apart. Take a breath and proceed through the problem one step at a time. And then simply divide by 0.24. And there are no units on that. All right. So there's no, again, don't attach percentages and decimals when there are none. All right. We had percents in the question. Of what number? Lastly, what, aka X, is 40% of 2. That one, there's not even anything to solve, right? 0.4 times 2. Again, still no percentage. That's not a percentage, right? So the answer there is 0.8. It's not 80%. All right, the good stuff. Here we go. Same thing. All right, read carefully. All right, make a picture if needed. Translate the problem to mathematical language. This is the biggest one. All right, of, is, at most, at least, all the words that represent mathematical language, right? Translate them as we go. And then again, decimals. Then carry out the calculation. And the other big one that I should note here, make sure you have your units, all right? When we're dealing in context, contextual solutions are important, all right? If it's asking for, you know, how much money, and you just write 70, right? Cents, dollars, thousands of dollars, millions of dollars, right? What are we talking about? So make sure you have your units attached. A tax exempt charity received a bill of $145.90 for educational software. The bill incorrectly included a sales tax of 6%. How much should the group pay? This is a very, very common one. I want to start with this one because percentages increase and decrease are one of the biggest things that I see people mess up. The temptation here is, oh, so you're trying to find the bill before the tax was added. So people are like, oh, multiply by 6%, subtract that off. That is incorrect. Okay. And actually, let's do it that way and we'll show. Okay, let's, first of all, this is the wrong way. The idea is, the reason this is wrong is this. When you calculate sales tax, tip, anything that increases upon the bill, right? You're actually multiplying by that value, then adding it to the total, right? That is, you're actually multiplying by, let's say something has 10% tax, you're multiplying it by 110%. So you're increasing the total. But when you decrease it by 10%, that's not the same 10%. All right. Do that for that $110 example. When I multiply $110 by 10%, what number is that?
11.
11. When you subtract 11 off of 110, what do you get? 99. See how the math didn't work? Okay. And so this is the constant temptation. Okay. Which is why we don't want to do this. So you have to think back. If it has sales tax of 6%, that means it was 106% of the original value, whatever that is. That then resulted in $145.90. That's the math for tax, tip, etc. Then, but once I have this equation, this is super easy to solve. What do I do?
Divide by 1,
Divide, right?
0, 6.
Now, notice, are those two values close?
Yeah.
Yeah. Were they close with, I mean, the $110 and the 100 resulting in 99? That was close. Okay. These values are going to be close. All right. But with money, is close usually good enough?
No.
No, people get very sensitive about money. All right. So close is never acceptable when it comes to money. Okay. Along those similar lines, and this is what I was talking about with percent increase, percent decrease, reduction, and things like less. Oreos reduced fat cookies contain 35 calories of fat in each serving. This is 40% less than the fat content in regular Oreos. How many calories of fat are in a regular serving of Oreo cookies? So this is once again, all right, 40% less. That means how much of the original is it?
60.
How much?
60.
60, right? So even though it's a decrease, we need to think back to the original, just like we did with this one. All right. 6% on top of the original. This is actually just 60% of the original. And so we're using this math and you have to subtract it from 1 in order to get this starting value. 60% of the original results in 35 calories of fat. setting these problems up, understanding this language is the toughest part. Because the actual algebra here is nothing. I mean, it's one-step algebra. But creating this equation, that's the thought part, which is why, again, and why I'm like, most of the time, like when I do these, it's in the calculator, I don't even write any steps. Because that's the thought part, the thought is done, then it's computer work. $58.33, is that good? That's the answer?
No, it's
No.
calories. Calories.
Calories.
I have calories on mine.
All right, units. The apartments in Jonathan's apartment complex are numbered consecutively on each floor. The sum of his number and his two neighbors' numbers, apartment total 2130. What are the apartment numbers? So, we use X a lot, all right? And sometimes we define X, sometimes I don't when it's obvious. The more complicated it gets, you sometimes want to say, oh, X equals, whatever, Jonathan's apartment. John's apartment. The more complicated this gets, you can also, I like using letters that make sense. Apartment numbers, I mean, I could use, I don't know, C, N, A, whatever variable you like, but it never hurts to identify, all right, the context of the values. So if X is John's apartment, all right, we have his two neighbors and the sum, right? The sum of all those. So we have his neighbors and the sum of all those become 2130. So then the apartments are numbered consecutively, which means is there an equation I could put in here for what his neighbor on the left would be?
X minus one.
X minus one. And then on the other side, and then then this is really super easy, right? X minus one, X plus one, all right, those go away. So we have, what does that all become?
3x equals 2130.
Divide by 3, divide by 3. X equals 710. All right, so the three apartment numbers are
710, 79, 711.
and then does that all add to 2130? And we could check that, but it's obvious with math, right? So again, piece at a time. A rectangle has a perimeter of 92 meters. The length is 4 meters longer than the width. What is the length and width of the rectangle? So this one, we need to kind of remember the formula for perimeter. What is the perimeter formula for a rectangle? Or let's start with, what's the concept of perimeter?
It's the outside. So that would be 2 width plus 2 length.
Summing the outsides, yes. All right, so yes, the formula for perimeter of a rectangle, 2L plus 2W. And again, when you have length and width, easy to use L and W instead of X's and Y's. So we have the equation of perimeter, and then I say 2L plus 2W equals 92, since that was given. And then, all right, this one I'm gonna need a second equation, all right? That's not sufficient. So I can read that next sentence out. The length is, what does this mean?
Equals.
4 meters longer 4, and then what mathematical operation you think that means?
Plus.
Plus, right? Longer, add the width. When you create these equations, I was like, we just read it right out, right? I mean, it's the mathematical language translates just directly sometimes. And then with this, all right, does anyone remember, I have 2 equations with 2 unknowns. Does anyone remember how we do this?
Replace one,
Yeah,
what L
Put the
equals.
L equals in the.
Yeah, I'm gonna put this guy, since that one's the easy one, I'm gonna put that guy into the big one. So 2, I'm gonna replace L with 4 plus W. Plus 2W equals 92. And then what? And just be aware, all right? We haven't fully done the dance, okay? So, all right, we're gonna see lots of steps of the dance. All right, what operation are we about to do here? Rainbow, all right? Everyone rise just for a minute. And we're gonna do this repeatedly as we go throughout the semester. I didn't want to do this to you on the first day to punish you, okay? No, we don't have to, that was just me. I would just say rise. Okay, so, all right, the rainbow goes like this, all right? Do the rainbow, do the rainbow, do the rainbow. Okay, very important hip hop here, okay? All right, do the rainbow, do the rainbow, all right? I wanna see that hip hop, okay?
Sometimes for decimal point movement.
For decimal point?
Yeah, for moving it. Yeah.
Oh, for like moving the decimal point in metric?
Yeah, yeah.
All right, that's it. Okay, and I do that. All right, we're gonna do several of these math dance steps just because of how important these pieces are. This is about the, Jesus, 20th time we've rainbowed, right, in 2 days, okay? It is very, very important, and I want you to remember these steps, all right? These simple things, all right, that cause the most issue because rainbow is almost always the first step. If you mess up the rainbow, you have trouble the rest of the way. Okay, so rainbow away. And then simplify, I'm gonna combine 2 W's.
Was 4W plus A equals 92.
And once again, all right, we're to 2-step algebra. I'm gonna subtract and divide. Nothing, easy peasy from there, right? The hard part, this last step, all right, we're gonna, I mean, these are definitely in the My Math Lab and stuff like that. This, you should practice ad nauseum until it's basically muscle memory, okay? The thought process ended once you set up the equations, and then there's just a couple of, rainbow remember steps. Yeah, 84.
When you plug that back in, it doesn't.
Go ahead.
You plug that back in, it doesn't add up.
Yeah, it does. If you,
25 plus 25 is 50. 21 plus 21 is 42. 50 plus 42 is 92. Absolutely very important. The step that I'm the worst on is what step?
Plugging it back in.
The check step, right? Plugging it back in, 100%. I completely agree. Check your answer. Make sure it made sense. This is not some fictional number we're looking at, right? I mean, this is perimeter, all right? Okay, and then one last thing. Are these the correct answers? 21 and 25?
Yeah, now that I did the math right.
No, those are not the correct answers.
no, meters.
Meters.
Oh, yeah.
Sorry.
All right, units, units, units. That's the biggest thing. The sentence goes that if you start in words, you end in words. All right. Used to be that, if you start with a sentence, you end with a sentence, but sentence feels like a lot. I was like, units is all that really matters. Okay. Because at that point, that is technically a mathematical sentence. The width is 21 meters, right? The length is 25 meters. That is a mathematical sentence. All right. That is just beautiful, beautiful stuff. As for today, all right, We are lucky enough that we actually have two, count them, two activities. All right, chapter 2, activity 2, and chapter 2, activity 3. All right, as well as finish up the chapter 2, activity 1. All right, that I know we were kind of pressured on time wise last time, but otherwise, I was like, take a look, go nuts. I'm gonna do roll and all that fun stuff.